Okay, I have set up this lab for the ENCOR exam. I have tried to include most of the infrastructure protocols, layer 2 protocols, routing protocols, overlay protocols such as Lisp and VXLAN, also IPsec, GRE, and so on. It is quite a large lab, so I have decided to split it into several sessions. In this case, we are going to focus on this topic, 3.1a, troubleshoot static and dynamic AO2.1q trunking protocols. Before jumping into the lab, we are going to talk a little bit about theory. I'm going to focus mostly on the troubleshooting part of the theory, and then we're going to jump into the lab. So trunk ports allow us to transport tagged and untagged frames, opposite to access ports that only transport untagged frames. Why do we need trunk ports? Because we need a way to communicate frames that belong to different VLANs in different switches across a single link. This single link is the trunk, and we are able to do so with the help of an encapsulation protocol, where this encapsulation protocol will be in charge of identifying each frame in such a way that I am able to know to what VLAN each frame belongs to. The regular Ethernet frame does not have a field to identify VLANs, so I need another protocol that helps me doing so. We have two options in Cisco. Cisco ISL, which is a Cisco proprietary protocol, mostly deprecated now. It is only found in old switches, and we rather use nowadays AO2.1q, which is a standard. It doesn't encapsulate, but rather tags frames, inserting fields into the Ethernet frame header. It adds 4 bytes to the header. It is universally available. Let's see what are the AO2.1q fields. First of all, we have the tag protocol ID, which is always this number. Every single frame that uses AO2.1q will begin with this number as the tag protocol ID. Next, we have the priority code point. We can use this 3-bit field in order to mark traffic, in order to later on configure quality of service. All of this is defined in a smaller standard that is known as AO2.1p. An interesting note here is that while most devices can read this field that is usually known as COS, not many devices are capable of writing it. So check your device feature list in order to see if your device supports actually writing COS values into your frames. Now we have another field here that is the VLAN ID that belongs to the AO2.1q header, which is a 12-bit field. It is the field that actually lets me identify to what VLAN each frame belongs to as it travels through a trunk link. Just a note here, you have to memorize this Cisco proprietary VLAN classification. Cisco established that these VLAN numbers belong to the normal or standard VLAN range. These VLAN numbers belong to the reserved VLAN range, and these VLAN numbers belong to an extended VLAN range. You have to memorize that. VLAN 1 exists in every device. You cannot delete it. You cannot use VLAN 0, and you are better off not using this VLAN number because it is undocumented. Now you can define a native VLAN on your trunk port. Untagged frames being sent and received on a trunk port belong to the native VLAN. This is the way to configure what is the VLAN number, your native VLAN number. And now here it comes a command that not many people use. But if you want that your frames belonging to your native VLAN are also tagged, you can use this command. So with this command, you are actually disabling your trunk interface to send or accept untagged frames. The best practice for the native VLAN is using a non-existing VLAN as your native VLAN and repeat this configuration throughout all your switching domain in all your trunks. You can also set up an allowed VLAN list on your trunks. This means that only frames belonging to the VLAN list are that are allowed to be sent over a trunk port. You can set up your VLAN list this way, and it is recommended that once that you have an existing working operating VLAN list, if you want to manage it, always use add and remove parameters in order to work with it. Otherwise, you can override your VLAN list by a human error. Now, let's talk about DTP, which is the dynamic trunking protocol that Cisco has. It's a Cisco proprietary protocol that negotiates two things: whether a port becomes a trunk or whether using AO2.1q or ISL as the encapsulation protocol for that trunk. If DTP is unsuccessful, the trunk will remain as access. So what we want with DTP is negotiating successfully and with the other side whether to become a trunk or to stay as access. So in order to do so, DTP sends frames, and we have two ways to configure DTP in order to negotiate a trunk: using dynamic auto that won't send frames, DTP frames, until receiving one from the other side. You can also use the dynamic desirable mode. In this mode, DTP always sends DTP frames. So dynamic auto is like a passive way, and dynamic desirable is more active. So you have several combinations here. At both sides you use mode auto. Both sides will remain in access and neither will become trunk. Other combinations will successfully negotiate the port into becoming a trunk port. Now the second function of DTP is negotiating using ISL or AO2.1q. If you don't do anything, by default, if both switches support ISL and AO2.1q, DTP will try to use ISL. Why? Because it is Cisco. However, you can influence DTP in order to choose another protocol. For instance, if you want AO2.1q, you can issue this command at one side only or on both sides. So if at least in one side you issue one of these commands, DTP will use that protocol. However, if you establish different protocols on both sides, the port will remain in access and a trunk port will not be established in either switch. Now you can also go for static trunks, where you instruct your port to always become a trunk. In this case, you are not disabling DTP. The port is in trunk mode, but is still sending DTP frames. But if you don't want to send DTP frames, you can disable DTP altogether and issue this command: switchport non-negotiate. So several combinations happen here. If one side is using DTP and the other side is using static trunks with DTP, some things happens. If one side is using DTP and the other side is using a static trunk with DTP disabled, some other things happen. So these are the combinations that you must able to remember. And now the best practice is, now that you know what is DTP and what is it used for, don't use it. The best practice is using static trunks and disable DTP altogether. Now let's go for the troubleshooting part of the theory. We have mainly two commands in order to troubleshoot our trunks interfaces: show interface trunk and show interface switchport. So let's go for the show interface switchport. This command will let you know layer 2 configuration information and layer 2 operational information about your port. So the output of this command will usually use the words administrative mode and operational mode. Administrative mode refers to how you configure your ports, and the word operational refers to how your port is actually working in real life. So for instance, we have this configuration which is empty. If the configuration is empty, it means that by default is using DTP in auto mode. So we can make sure of that because the administrative mode tells me that it is dynamic auto. That is the default, and that is how the interface is configured. Now in real life, this interface is operating in a static access. That means that a trunk was not negotiated. Now we have configured nothing for the trunking encapsulation, so it is set to negotiate. That means that we are letting DTP do the encapsulation negotiation, but operationally it is not encapsulating anything. It is sending just untagged frames. That is the meaning of this native, and it is native because we are operating in access mode. DTP is working on this interface. That is why negotiation of trunking is on, and the access VLAN is 1 in this case. We are operating in access, so this output is valid. All of this output is meaningful for trunk ports. So given this is operating in access, all of this is meaningless. Now let's see another example. This port is configured as switch port mode dynamic desirable. We can see that because the administrative mode here reflects that. Remember that administrative is what you configure. Now it is operating in trunk, so in this example the negotiation of the trunk was successful, and we are by configuration letting DTP do its thing. It is going to negotiate whether to use ISL or .1Q, and in real life it is operating with ISL. So DTP reached a conclusion that it is going to use ISL, and it is actually doing so. And it is enabled because negotiation of trunking isn't on. This means that we are actually using DTP. This output is meaningless because we are operating in trunk mode. Now the native VLAN for this trunk is 1, the VLAN 1. It is being sent untagged, and this is my allowed VLAN list for this trunk. It is my prone eligible list for VTP. We have not touched that. We are going to talk about that in the BTP section. Let's see another example. In this example, we are using a static trunk. This is the configuration for the static trunk. We are saying that this port will go into trunk mode always. We want to use .1Q always, and we are disabling DTP. So by using show interface switch port, we can tell that this port was configured as a static trunk. So this is the way it was configured, and it is operating in trunk mode. The configuration for the encapsulation was set to .1Q, so we manually said that we want .1q, so that is why it is in administrative set to .1q, and it is operating in real life with .1q. The DTP is disabled with this command on negotiate. That is why it says that it is off. This is meaningless because we are operating in trunk mode. So we are only this is meaningful because these are output that belong to trunks. We are using the VLAN 1 as the native VLAN for this trunk. It is saying untagged. This is the list of allowed VLANs, and this is the prune eligible list for BTP. We have not talked about that. We're going to talk about prune eligible list in another session. Now this is the other interesting troubleshooting command for trunks. Show interface trunk. Show interface trunk tells you if you have trunk ports in your switch. In this case, we have 3 trunk ports. It tells you that they are trunking. It tells you the native VLANs of every single trunk, and it tells you the encapsulation that it is using. In this case, the letter N means that it was negotiated. It was not configured, but it was rather negotiated. So both ends negotiated that they are going to use ISL here, ISL here, and in this case for gigabit 03, this was configured manually. It was not negotiated. Gigabit 00 was configured as dynamic auto. Gigabit 02 was configured as dynamic desirable, and gigabit 03 was configured as a static trunk. Now we have something interesting here, which is the allowed VLAN list. In this case, if we don't establish an allowed VLAN list, we mean that all VLANs are permitted in this trunk. However, 2 filters are going to be applied to this all VLAN list. We first are going to evaluate from all these VLANs which ones are actually created and are in active mode. Only VLAN 1 passes this filter. And from this VLAN list, which ones are blocked by a spanning tree, for instance, per VLAN spanning tree plus, or rapid per VLAN spanning tree plus, and which ones are blocked by BTP pruning. So in this case, VLAN 1 passes this filter. So in order to understand this, there is this diagram. All VLANs are available. Then you set up a first filter using your allowed VLAN list. But then another filter is applied to your allowed VLAN list. Has all the VLANs that you established in your VLAN list being created and are inactive? Only VLANs that are active passes this filter. And then another filter is applied to these VLANs that pass the second filter. Is this VLAN is the port blocked for this VLAN due to spanning tree protocol? If yes, then it is discarded. Is this VLAN pruned by BTP? Then it is discarded. So all the VLANs that are not blocked due to spanning tree or not pruned by BTP will become the actual VLANs using the trunk. So that is the meaning of this output. So for instance, this is the other switch that is connected to the previous switch that we saw. We have 3 trunks. They were configured as dynamic desirable. They are trunking. They are using the native VLAN number 1. In this case, it was negotiated. The trunking protocol was negotiated, and these 2 first trunks, the ISL protocol was negotiated, in the search trunk, the AO2.1Q was negotiated. Now, regarding the VLAN allowed, the allowed VLAN list, we don't have any, so by default, all VLANs are allowed in the trunk, but we have to filter all those VLANs to the first filter or second filters, because the first filter is your allowed VLAN list. Is of these VLANs, how many are active? In this case, only VLAN 1 is active. Now, let's apply the third filter. From these VLANs, which ones are not blocked by a spanning tree or pruned by BTP? In this case, only gigabit 0 can pass frames for VLAN 1. The other ones will not pass any frame at all. And these are VLAN 1 is being filtered from these trunks because a spanning tree is telling so. So, given these ports are in blockade mode for gigabit 02 and 03, VLAN 1 is filtered out. So, some final notes on troubleshooting trunks. Remember that every single device that supports AO2.1Q can have or can be connected through a trunk. Not only firewalls to routers, not only routers to switches, not only switches to switches. You can configure switches to servers. As long as the server understands AO2.1Q, you can connect a trunk in there. Now remember your DTP. DTP won't negotiate a trunk if both sides are configured as auto. Auto is the default. DTP won't negotiate a trunk if both sides are configured with different protocols. DTP won't negotiate a trunk if BTP domains mismatch. This is a BTP thing. If one switch is using one certain domain, BTP domain, and your other switch is using a different BTP domain, DTP will negotiate a trunk there. And finally, remember that your native VLAN number must match on both sides, otherwise you will get warnings. So that is this is the summary of what we have talked about. Now let's jump into the lab. What we want to do with this lab is configure some trunks. We are going to configure Access A, Switch 3, Switch 4, Nexus 3, and Nexus 4. We are going to configure dynamic trunks between Access A and Switch 3, and Access A and Switch 4, and we are going to set up static trunks between Switch 3 and Switch 4, and on this part of the network we are going to use in this green part of the network we are going to set up only static trunks. So let's jump into Access A. And set up dynamic trunks to Switch 3 and Switch 4. So for instance, if I issue show interface trunk, I don't have any trunks whatsoever. So let's see how my interfaces are configured. For instance, gigabit 00 is empty. If I issue show interface gigabit 00 switch port, it is configured as dynamic auto, which is the default. I don't see that dynamic auto here because it is the default, and it is operating as access. So let's do that configuration in one go. For instance, I could do interface range from gigabit 00 to 3, because I'm going to configure gigabit 00, 01, 02, and 03. So this is going to be dynamic, so switch port mode dynamic desirable, then switch port trunk allowed VLAN list. I'm going to use VLAN 10 for management, VLAN 100 for users, 100 for voice over IP, and 102 for guests. And then remember that we are going to use a native VLAN that doesn't exist for security, and that should be it. Let's issue no shoot. Let's see, show interface strong. Now I have 4 trunks. They negotiated ISL. I don't like that. Let's fix that. SWITCHPORT trunk encapsulation.1q. Okay, now we have 4 trunks between Giga Access A and the distribution switches. We are going to receive this this warning because I used a different VLAN. Most switch 3 and switch 4 are using the default VLAN, which is VLAN 1, and I chose an unexisting VLAN on access B. So let's fix that. So for instance, the interfaces that go to access A are 2.0 and 2.1. So let's fix that. Interface range gigabit 2.0 to 1. Switch port trunk native VLAN, and let's set up a low VLAN 10 and 100 to 102. Okay, and now let's set up the trunks that go from switch 3 to switch 4, which are gigabit 10, 11, 12, and 13. We're going to use static trunks there. So interface range gigabit 10 to 3. These are 4 links that go from switch 3 to switch 4. Later on we are going to set up an enter channels here, but for now we are configuring trunks. So switch port trunk encapsulation.1q, switch port mode trunk. I am using a static trunks here, and I'm going to disable in these interfaces DTP switch port trunk native VLAN. Remember that the best practice is using a non-existing VLAN for your native VLANs, and then the allowed VLAN 10 for management, 100 for users, 101 for voice over IP, 102 for guests. No shoot. Let's go for switch 4 and let's configure first. Remember that we are using dynamic trunks to the access switch, so interface range gigabit 2.0 to 2.1. I'm gonna leave this as dynamic. I'm just going to set up the native VLAN to stop the warnings, and the switch port allowed VLAN list. 10 and 100 to 102. Then let's configure the trunks that go from switch 4 to switch 3. So it will be interface range gigabit 10 to 3, switch port trunk encapsulation .1q, switch port trunk mode trunk, switch port non-negotiate, switch port native switch port trunk native VLAN 33 and switch port trunk allowed VLAN 10 for management 100 to 102. So show interface trunk here just to validate. These are my trunks to switch 3. On says that I am using static trunks and I am using DTP to create my trunks to the access switch. Same must happen here at switch 3. Show interface trunk. I have 4 trunks that go to switch 4 that are set up in static trunk mode, and I have 2 trunks that go for the access switch. Notice that no VLAN is being sent because these VLANs that I established in the allowed VLAN list 10, 100, 101, they do not exist. They are not active. That is why from this list we go to this list. None, because they are non-existent. That is the second filter. So at this point in time, no frames can travel these trunks because I have not yet created VLAN 10, 100, 101, and 102. Let's see how my trunks show up in access, in the access switch. I have these 2 trunks for switch distribution switch 3 and these 2 trunks to distribution switch 4. This is my allowed VLAN list, and I have none here because these VLANs do not exist yet. Show VLAN ID 10 does not exist. Okay, let's go for these Nexus switches and do the same. I'm going to use only static trunks. Okay. From Ethernet 1.5 to 9, which are these, I'm going to execute switch port to turn these ports into layer 2 mode, because in this particular version of Nexus, this operating system will set them all in layer 3 mode. So switch port to turn them into layer 2 mode, then switch port mode trunk, switch port trunk native VLAN and non-existing VLAN. For security, switchport trunk allowed VLAN 10 and 100 to 102, and that's it. The same for interface 813 switchport mode trunk. Okay, 13 is this interface. And then let's configure Nexus 4. We're going to do the same. We're going to use a static. I believe by default DTP is not enabled in probably I have to enable if I wanted to use DTP. No, I cannot use DTP here. So from five to 9. Oh, we don't use range here. Switchport mode trunk, switchport trunk native VLAN, non-existing VLAN, switchport trunk allowed VLAN list, and that will be it. And we need to configure this interface 14. That is the trunk that goes from Nexus 4 to my access switch. Switchport mode trunk, switchport trunk native VLAN, switchport trunk so what happens if I issue show interface trunk? So these are the interfaces that I just configured, 5 to 9 and 14 are trunking. This is my allowed VLAN list. This is my native VLAN, not this. I am using the same. And then given these VLANs that I established in the allowed VLAN list do not exist yet, they are set to none. Now, just as a comment here, this device is a router and I am simulating breaches here using bridge domains. So this is a router, this is CSR 1000V. This is actually a router, but it is behaving as a switch because I have bridge domains here. So this is the way to create bridge domains. This will be VLAN 10, VLAN 100, VLAN 101, and so on. Okay, so that will be it. We have our trunks working now. That's it.